March 1944. Recklinlerz Airfield, Mecklenburg, Germany. The systematic examination of captured enemy aircraft had become a critical function of the Luftwaffe's Technical Intelligence Service. At Erprobungsstelle Rechlin, the Reich's primary aircraft testing and evaluation center, teams of engineers and pilots worked to understand every advantage the Allies possessed in the air war. What they discovered in the early spring of 1944 would fundamentally alter their understanding of American industrial capacity and the future of the air war over Germany. The captured P-51 Mustang arrived at Rechlin on March 6, 1944, transported by rail from a crash site near Brandenburg. The aircraft had been shot down 2 days earlier during the first American fighter escort mission to Berlin. The pilot had not survived the impact, but the airframe remained largely intact, providing German technical staff with their most complete example yet of the aircraft that was rapidly changing the balance of air power over the Reich. Hauptmann Werner Baumbach, who served in aircraft development and would later command Kampfgeschwader 200, oversaw the initial examination. The young American pilot's navigation charts, still in the cockpit, showed the route from an airfield at Debden in England to Berlin and back, a distance of over 1,100 miles round trip. The technical evaluation began immediately. German intelligence had been tracking reports of increased American fighter activity deep over German territory, but the official assessment remained that single-engine fighters lacked sufficient range to escort bombers to Berlin. The distance from English bases to the German capital measured approximately 560 miles one way. Standard fighter aircraft, even with external fuel tanks, could not carry enough fuel for such a mission while maintaining combat capability. This assessment had been based on analysis of earlier captured P-47 Thunderbolts and P-38 Lightnings, both of which had demonstrated limited penetration into German airspace before fuel constraints forced them to turn back. The events of March 4th and 6th, 1944, had shattered these assumptions. On March 4th, P-51 Mustangs from the 4th Fighter Group, flying their first mission in the new aircraft after transitioning from P-47s just days earlier, had escorted a small bomber force to Berlin. Weather and communication problems limited the effectiveness of this first mission, with only 32 bombers reaching the target. But the significance was unmistakable. American single-engine fighters had reached Berlin, engaged in combat, and returned to England. 2 days later, on March 6th, approximately 660 bombers attacked Berlin in daylight, escorted by over 150 P-51 Mustangs, along with P-38 Lightning and P-47 Thunderbolt groups. The escort fighters engaged Luftwaffe interceptors over the German capital and accompanied the bombers home. This was not a fluke or a one-time penetration. The Americans had solved the escort fighter problem. General Major Adolf Galland, General der Jagdflieger and one of Germany's most successful fighter aces with over 100 victories, had flown combat missions during this period despite his administrative position. He encountered P-51 formations over Germany and immediately recognized the implications. His combat assessments, submitted through official channels, noted that American fighters were operating at full combat capability over Berlin, engaging aggressively with no apparent fuel conservation behavior. They were not flying at the limits of their range. They had reserves. This contradicted everything Luftwaffe intelligence believed about American fighter capabilities. Galland's reports emphasized the P-51's superior performance at high altitude, where it outmatched both the Messerschmitt Bf-109 and Focke-Wulf FW-190 in speed and maneuverability above 20,000 feet. The technical examination at Rechlin focused first on determining how the Americans had achieved this range. The evaluation team measured the P-51B's internal fuel capacity. The aircraft featured 2 wing tanks, each holding 92 gallons of aviation fuel, for a total of 184 gallons in the wings. Additionally, the fuselage contained an 85-gallon fuel tank, positioned directly behind the cockpit. This fuselage tank had been a relatively recent addition to the P-51B design, incorporated during production to extend range. Total internal fuel capacity was 269 gallons. The Packard-built Merlin engine, a license-produced version of the Rolls-Royce Merlin that had transformed the Mustang's high-altitude performance, consumed fuel at rates that varied with power settings. At economy cruise settings, the engine burned approximately 60 gallons per hour. At normal cruise power, consumption increased to approximately 75 gallons per hour. German engineers performed range calculations using these figures. With 269 gallons of internal fuel and consumption of approximately 70 gallons per hour at cruise settings, the P-51B could fly for roughly 3.8 hours. At the aircraft's cruising speed of approximately 300 miles per hour, this yielded a maximum range of 1,140 miles. This was precisely enough to reach Berlin from English bases and return, but only barely, with no reserves for combat operations. Yet combat reports clearly indicated the American fighters had engaged in prolonged dogfights over Berlin, sometimes lasting 15 to 20 minutes, before disengaging and flying home. Combat power settings consumed fuel at rates exceeding 100 gallons per hour. Such fuel expenditure should have left the aircraft unable to complete the return journey. The calculations did not explain what German pilots were observing in combat. The answer became apparent when technical staff examined the aircraft's wing structure more carefully. The P-51B featured standardized hardpoints under each wing, designed to accommodate external stores. These attachment points included fuel line connections, indicating they were designed specifically for external fuel tanks. Drop tanks were not a new concept. German fighters had used them since the Battle of Britain. The Bf-109 could carry a 300-litre drop tank. The FW-190 regularly employed them for extended-range missions. Drop tanks allowed aircraft to carry additional fuel externally, then jettison the empty tanks before entering combat to reduce weight and drag. This was standard practice for all air forces. The question was not whether the Americans were using drop tanks, but rather what capacity these tanks had, and how the Americans were producing enough of them to maintain operational tempo. The search for American drop tanks from the March missions began immediately. Intelligence officers plotted likely jettison points based on the engagement locations reported by Luftwaffe pilots. Drop tanks would typically be released when enemy fighters were encountered, as the external stores reduced maneuverability and speed. Search teams composed of Wehrmacht personnel and Hitler Youth volunteers spread across the countryside northeast of Berlin, looking for any debris from the air battles. Within 3 days, several objects were recovered from fields and forests in the region. Most were fragmentary, crushed on impact or damaged by the fall. But 2 examples arrived at Rechlin in relatively intact condition, having landed in soft soil or winter wheat that cushioned their impact. The captured drop tanks revolutionized German understanding of American industrial methods. The tanks were cylindrical, measuring approximately 108 inches in length, with a diameter of roughly 22 inches at the widest point. Capacity calculations indicated each tank held approximately 108 US gallons, or roughly 400 litres. 2 such tanks would provide 216 additional gallons of fuel, extending the P-51's total fuel capacity to 485 gallons. With this fuel load, the Mustang could fly for approximately 6.7 hours at cruise power settings, yielding a range exceeding 2,000 miles. This was more than sufficient for the Berlin mission with substantial combat reserves. The fuel capacity mathematics now made sense. But what captured the immediate attention of German engineers was not the capacity of the tanks, but rather their construction. The drop tanks were not made of metal. Running a hand along the surface revealed a texture unlike aluminum or steel. The silver paint coating the exterior could not disguise the fundamental nature of the material beneath. When engineers carefully scraped away a small section of the paint near the tail cone, they found multiple layers of heavy paper, each layer perhaps 0.5 millimeter thick, compressed and laminated together with a resinous adhesive. The construction was sophisticated and purposeful. The nose cone and tail cone were formed from overlapping pieces of the paper material, pressed into shape like papier-mâché. Each piece was visible as a slight ridge where it overlapped with adjacent pieces, creating a scalloped texture. The center section was seamless, wrapped around a cylindrical form in continuous layers. The fuel fittings were brass, precisely machined and properly sealed. Peering through the filler cap revealed an interior coated with what appeared to be a cellulose-based lacquer, designed to resist the corrosive effects of aviation gasoline. German materials specialists were brought in to analyze the tank's construction in detail. The paper was identified as kraft paper, manufactured using a chemical pulping process that produced exceptionally strong cellulose fibers. This was the same material used for heavy-duty shipping containers and industrial packaging. The adhesive proved to be a resorcinol formaldehyde resin, a thermosetting polymer that created bonds stronger than the paper itself when heat-cured. The lamination involved at least 12 separate layers of paper, each one carefully oriented to provide strength in multiple directions. Anti-slosh baffles made of wood were installed inside to prevent fuel from surging during maneuvers. The entire construction process was clearly standardized and designed for mass production. Most significantly, the empty tank weighed approximately 80 pounds, compared to 65 to 75 pounds for a comparable metal tank of smaller capacity. The paper construction was not significantly lighter than metal, but it offered other advantages. The implications were immediately clear to the technical staff at Rechlin. The Americans were manufacturing fuel tanks from non-strategic materials. Paper and wood-based resins did not require the aluminum, steel, or other metals that were increasingly scarce in wartime economies. The manufacturing process required no specialized metalworking equipment, no skilled metalworkers, no welding or forming of sheet metal. These tanks could be produced in any paper mill or packaging factory with relatively simple modifications to existing equipment. The United States had hundreds of such facilities. If even a small percentage of American paper production had been converted to drop tank manufacturing, output could reach thousands of units per week. The tanks appeared to have no serial numbers, no manufacturer markings, nothing to indicate limited production. They were commodity items, mass-produced and completely expendable. Intelligence officers began researching American paper industry capacity. The United States produced approximately 12 million tons of paper annually before the war, with production increasing during wartime mobilization. Converting even 1% of this capacity to drop tank production would yield over 100,000 tanks per month, far exceeding any plausible requirement for P-51 operations. The real constraint would not be materials, but rather the availability of manufacturing equipment and labor to assemble the tanks. But this was precisely the type of manufacturing that could be performed by semi-skilled workers after minimal training. The paper tanks represented industrial efficiency and resource optimization on a scale that German planners found difficult to comprehend. Further analysis revealed additional details about the paper tank's design and use. The tanks were strictly single-use items. The resorcinol adhesive, while creating strong bonds when cured, was slowly dissolved by prolonged contact with aviation gasoline. Intelligence reports and interrogation of captured American aircrew indicated that paper tanks had to be filled immediately before flight and could not be stored filled for more than a few hours without developing leaks. This was not a limitation that affected operational use. Fighters were fueled as part of their pre-flight preparation. The tanks would be used for a few hours during the mission, then jettisoned. The single-use nature actually simplified logistics. There was no need to recover and reuse the tanks, no need for cleaning, inspection, or maintenance. They were expendable by design. The German evaluation also noted the color coding of the tanks. Paper drop tanks were painted silver, while metal tanks used by American forces were painted grey. This color distinction allowed ground crews to quickly identify tank types during fueling operations. The silver finish on paper tanks also helped reflect solar heat, reducing fuel evaporation and vapor pressure issues at altitude. Every aspect of the design reflected systematic engineering optimization for mass production and field use. By late March 1944, German intelligence had traced the origin of the paper drop tanks to British development. The Air Ministry in London had commissioned development of impregnated paper fuel tanks in 1943 to conserve strategic metals, particularly aluminium. The Bowater-Scott Corporation, utilising expertise in paper manufacturing, developed the production process. The tanks entered service with RAF fighter squadrons in late 1943. American forces quickly adopted the design, with multiple manufacturers in both Britain and the United States producing tanks for use by USAAF fighter groups. The innovation had been driven by British resource scarcity, but was being exploited on a massive scale by American industrial capacity. The broader implications extended far beyond fuel tanks. German technical staff began a systematic review of captured American equipment, looking for other examples of industrial innovation and mass production techniques. The results painted a consistent picture. American equipment was not always technologically superior to German equivalents in terms of individual component performance. German optics were often better. German small arms were often more sophisticated in design. German armour metallurgy was in some respects more advanced. But American equipment was consistently better manufactured, more standardized, more reliable, and available in vastly greater quantities. The American approach prioritized producibility over perfection. Components were designed from the outset for mass production by semi-skilled workers using standardized tooling. Parts were interchangeable between units without hand-fitting. Assembly line methods reduced production time and increased output. The contrast with German production methods was stark. German weapons and equipment were often technical masterpieces, hand-fitted by skilled craftsmen. A German tank or aircraft engine represented the peak of precision engineering, but building such equipment required skilled labour, specialised tools, and significant time per unit. Production rates were constrained by the availability of master craftsmen and precision manufacturing equipment. The Germans built superior individual items. The Americans built adequate items in overwhelming quantity. In industrial warfare, quantity had proven decisive. Analysis of P-51 Mustang production illustrated this principle. North American Aviation had designed the original Mustang prototype in response to a British requirement in 1940. The prototype NA-73X was completed just 117 days after the contract was signed, one of the fastest design-to-prototype cycles in aviation history. The first flight occurred on October 26, 1940. By 1944, North American was producing P-51 variants at 2 facilities. The Inglewood plant in California averaged approximately 364 Mustangs per month during peak production periods. The Dallas plant contributed additional production. Combined output across both facilities reached an average of approximately 574 P-51s per month during 1944, with production accelerating throughout the year. Peak monthly production would reach 881 aircraft in January 1945. Each P-51 required approximately 15,000 individual parts, manufactured by hundreds of subcontractors across the United States. The Packard-built Merlin engines were produced in Detroit at rates exceeding 300 units per month. Final assembly of a P-51D required approximately 22,000 man-hours of labour, but the production line system meant that completed aircraft rolled out of the factory at intervals of a few hours. At peak efficiency, a new Mustang was completed approximately every 2 hours. The scale and efficiency of this production system exceeded anything Germany had achieved. Messerschmitt and Fokker-Wulf combined produced approximately 600 fighters per month in early 1944. Despite operating under emergency priority programs and utilizing forced labor, German aircraft production could not match American output. The resource implications were equally sobering. American aluminum production in 1944 reached approximately 1.25 million tons, equivalent to £2.5 billion annually. This represented a massive increase from pre-war production of approximately 164,000 tons in 1939. Germany's aluminum production, by contrast, peaked at approximately 250,000 tons per year and was declining due to bombing of production facilities and loss of bauxite sources. The Americans had approximately 10 times Germany's aluminum production capacity. The decision to manufacture drop tanks from paper rather than aluminum was not driven by metal scarcity. The United States had sufficient aluminum to produce every drop tank in metal if desired. Paper was chosen because it was cheaper, required less critical manufacturing equipment, freed aluminum for other uses, and could be produced more quickly with less skilled labour. This was optimization, not desperation. The psychological impact of these revelations spread through the Luftwaffe technical and operational communities. The paper drop tank became a symbol of American industrial capability and the fundamental disparity in resources between the combatants. Captured examples were displayed at technical briefings for Luftwaffe personnel. Pilots transitioning to fighter units were shown the tanks and asked to calculate the implications for combat tactics. The message was clear. American fighters could now escort bombers anywhere in Germany. The previous defensive strategy of waiting for Allied fighters to reach their fuel limits and turn back was obsolete. Luftwaffe fighters would have to engage the escorts to reach the bombers, and those engagements would cost aircraft and pilots at rates Germany could not sustain. Galland provided the operational assessment in conferences with senior Luftwaffe leadership throughout the spring of 1944. The P-51 was superior to German fighters above 20,000 feet, he emphasized repeatedly. It was faster than the Bf-109 at altitude, and more maneuverable than the FW-190. With the extended range provided by drop tanks, it could escort bombers throughout their mission profile. German fighters could no longer attack bomber formations unopposed after Allied escorts turned back. Every intercept now required fighting through the fighter screen. Loss rates were climbing steadily. In January 1944, the Luftwaffe lost approximately 90 fighters, while claiming approximately 150 Allied aircraft destroyed. By February, German losses had increased to approximately 160 aircraft against approximately 230 Allied losses. The trend was clear and unsustainable. The Americans and British could replace losses faster than Germany could inflict them. The summer of 1944 brought the full impact of American escort fighter capability. The 8th Air Force conducted deep penetration raids almost daily when weather permitted. Mustangs provided continuous escort from England to targets across Germany and back. Luftwaffe fighter losses mounted catastrophically. In June 1944, approximately 350-day fighters were lost defending the Reich. In July, losses exceeded 350 single-engine fighters in the West alone, representing a 31.2% monthly attrition rate. August saw similar losses with a 36% attrition rate. At these loss rates, experienced pilots were being killed faster than they could be replaced. The replacement pilots arriving from training schools had perhaps 150 hours of flight time, compared to 300 hours or more for American pilots. Many German replacement pilots had as little as 30 hours in type before being assigned to operational squadrons. The experience gap, combined with numerical inferiority and the constant presence of P-51 escorts, made daylight operations over Germany increasingly deadly for the Luftwaffe. Galland submitted repeated assessments to Hitler and senior Wehrmacht leadership throughout this period. His September 1944 report stated the situation bluntly. The Luftwaffe could not win the air war. Germany lacked the resources, the fuel, the aircraft, and the trained pilots necessary to contest Allied air superiority. The Americans could replace losses faster than Germany could inflict them. Their industrial capacity was beyond Germany's ability to counter through combat operations. The only viable strategy was to husband remaining resources for defence of critical targets and hope for political settlement before complete collapse. The paper drop tanks continued to fall across Germany throughout late 1944 and into 1945. German civilians learned to recognise the distinctive cylindrical shapes lying in fields and forests. Initial reports sometimes described them as unexploded bombs, causing local panic until military authorities identified them as harmless fuel tanks. Instructions were distributed through civil defence organisations explaining that the silver cylinders falling from Allied aircraft were empty fuel tanks, not weapons. The psychological impact was noted in civilian morale reports. The sight of enemy aircraft overhead in such numbers that their contrails crisscrossed the sky, casually discarding expendable fuel tanks, reinforced the message that the Allies had resources to waste, while Germany scraped for every litre of fuel and every kilogram of aluminum. Technical intelligence continued analysing captured American equipment throughout 1944, but the focus shifted from understanding capabilities to documenting the scale of industrial disparity. Could Germany manufacture similar paper drop tanks? The technical answer was yes. German chemical industry could produce suitable resins. German paper mills could manufacture kraft paper. The manufacturing process was not particularly sophisticated, but the practical answer was no. Germany's chemical industry was already operating at maximum capacity, producing synthetic rubber, explosives, and other critical materials. Resin production for non-essential items could not be prioritized. The paper industry was fully committed to military requirements for maps, documents, and packaging. Most critically, there was no operational requirement for extended-range drop tanks. By late 1944, fuel shortages were grounding large portions of the Luftwaffe. Pilot training was reduced to minimal levels. Operational sorties were limited by fuel availability rather than aircraft availability. Building drop tanks to extend range was meaningless when there was barely enough fuel for local defensive operations. The irony was stark and bitter to German planners. The Americans had solved the fighter range problem with paper fuel tanks at exactly the time when German fighters were grounded by fuel shortages. Different problems, different industrial bases, different outcomes. The Americans had more of everything: more aircraft, more fuel, more pilots, more aluminum, more industrial capacity, and sufficient excess capacity to optimize solutions like paper drop tanks. Germany was fighting a war of scarcity against an enemy for whom scarcity was not a constraint. By January 1945, the war's outcome was beyond doubt. Soviet forces were approaching the Oder River, less than 50 miles from Berlin. Western Allied forces had recovered from the Ardennes offensive and were pushing toward the Rhine. The Luftwaffe could mount only sporadic resistance, limited by fuel availability and pilot losses. The systematic study of American equipment continued at Rechlin, but it had become an academic exercise. The findings were documented for the historical record, but they could no longer influence the war's outcome. The final comprehensive analysis of the P-51 and its drop tanks was prepared in late January 1945. The report documented every technical aspect of the Mustang's range capability, the drop tank construction methods and materials, production estimates, and operational implications. The conclusion was unambiguous. The P-51 Mustang, equipped with expendable paper drop tanks manufactured from non-strategic materials, has rendered the German heartland indefensible against American daylight bombing. Germany lacks the industrial capacity to match American fighter production, the fuel to sustain combat operations at the required scale, and the trained pilots to replace losses at current attrition rates. The report was filed in the Reich Air Ministry archives in late January 1945. Whether senior leadership read it is unknown. By then, technical reports analysing American capabilities were simply confirming what battlefield reality had already demonstrated. The Luftwaffe, which had dominated European skies in 1940, was reduced to occasional desperate sorties by early 1945, hoarding precious fuel for missions that could not change the strategic situation. American fighters roamed freely over Germany, attacking targets of opportunity, escorting bombers, establishing complete air supremacy. Each paper drop tank falling from American aircraft was a reminder of the industrial disparity that had decided the air war. The June 1944 exhibition at Rechlin had displayed captured Allied aircraft to Luftwaffe personnel, including multiple examples of the P-51 Mustang alongside B-17 and B-24 bombers, P-38 Lightnings, Lancaster bombers, Mosquito fighter bombers, Typhoon fighter bombers, and various Spitfire variants. Thousands of Luftwaffe pilots and ground personnel toured the exhibition, examining enemy equipment firsthand. The paper drop tanks were displayed prominently, with technical diagrams explaining their construction and range implications. The exhibition served as both educational tool and sobering reality check. German personnel could see the quality of Allied equipment, the standardization of components, the evidence of massive production capacity. The overwhelming scale of Allied industrial mobilization was made tangible through the physical examples of equipment they faced in combat daily. Kampfgeschwader 200, the Luftwaffe unit responsible for special operations, including flying captured Allied aircraft, operated several P-51s throughout 1944. These aircraft were used for evaluation flights, allowing Luftwaffe test pilots to experience firsthand the performance characteristics that made the Mustang such an effective fighter. The reports from KG-200 pilots consistently noted the P-51's excellent visibility from the cockpit, particularly in the later P-51D model with its bubble canopy. The aircraft was stable in flight, responsive to controls, and possessed excellent high-altitude performance. The Merlin engine provided smooth, reliable power throughout the operating envelope. Most significantly, the range and endurance were extraordinary for a single-engine fighter. With full internal fuel and drop tanks, the P-51 could remain airborne for over 6 hours, flying missions that would have been impossible for German single-engine fighters even with external tanks. The technical understanding gained at Rechlin contributed to German defensive tactics in the final year of the war. Recognizing that American fighters could escort bombers throughout their missions, Luftwaffe fighter controllers attempted to concentrate forces at specific points to achieve local superiority. This required careful coordination and timing, as dispersed German units had to assemble at designated locations to create formations large enough to have a chance against the heavily escorted bomber streams. Fuel constraints and communication difficulties often prevented successful concentration. Even when German fighters achieved favorable positions, the presence of P-51 escorts made attacks on the bomber formations extremely costly. The tactical situation had fundamentally shifted. In 1943, unescorted or poorly escorted bomber formations had suffered catastrophic losses. By mid-1944, German fighters attempting to reach the bombers suffered the catastrophic losses. The paper drop tanks themselves became collector's items after the war. Very few examples survived intact, as most were destroyed on impact or deliberately crushed by Allied ground crews to prevent reuse by enemy forces. The expendable nature of the tanks meant they held little intrinsic value. The few that survived became museum artifacts and historical curiosities. The National Air and Space Museum in Washington maintains several examples in its collection, displayed alongside the P-51 Mustang aircraft they were designed to serve. The information placards note the construction from laminated craft paper impregnated with phenolic resin, the manufacturing by companies like Bowater Scott, and the capacity of 108 US gallons. The placards do not typically mention that German engineers spent weeks analyzing these tanks, calculating their implications, and understanding through them the full scale of Allied industrial superiority. The story preserved in technical reports and post-war interviews reveals the psychological impact on German technical personnel. They were not analyzing a superior weapon. The paper drop tank was not an advanced technology. It was, in fact, a deliberately simplified design using non-critical materials. But that very simplicity carried a message more devastating than any technical sophistication could have conveyed. The Allies had such overwhelming industrial capacity that they could afford to optimize designs for mass production rather than performance. They could manufacture fuel tanks from paper because they had unlimited paper, unlimited resin, unlimited manufacturing capacity, and unlimited fuel to put in the tanks. The optimization was not driven by scarcity, but by efficiency. Germany's experienced engineers understood immediately what this meant. They were not fighting an enemy that was desperately improvising with substitute materials. They were fighting an enemy so wealthy in resources that substitution was a choice made for efficiency, not a necessity imposed by shortage. Post-war interrogations of Luftwaffe personnel consistently returned to this theme. When asked when they first understood that Germany would lose the war, many technical staff and senior officers cited the early spring of 1944 as the turning point. The arrival of long-range fighter escorts over Berlin marked a decisive shift in the strategic balance. Hermann Göring, interrogated after the war, acknowledged that long-range fighters had delivered a major strategic blow to German defensive planning and were among the most decisive factors in the ultimate outcome of the air war. While the specific quote about Mustangs over Berlin remains unverified in primary sources, Göring's post-war statements consistently acknowledged that Allied air superiority, made possible by long-range escort fighters, had been decisive in Germany's defeat. The technical lessons learned by German engineers who examined captured P-51s and their drop tanks contributed to post-war aviation development. Many of these engineers emigrated to the United States or worked with Allied technical intelligence services after the war. Their detailed understanding of American production methods and design philosophy influenced their later work. The emphasis on standardization, interchangeability of parts, and design for manufacturability became standard practice in post-war aircraft development. The paper drop tank itself became a case study in wartime industrial innovation, taught in engineering schools and military staff colleges as an example of how resource optimization and mass production could provide strategic advantage. The P-51 Mustang continued in service with various air forces for decades after World War II. The aircraft saw extensive combat in the Korean War, serving primarily in ground attack and close air support roles. The excellent range and endurance that had made it an outstanding escort fighter in Europe proved equally valuable in the very different operating environment of Korea. P-51s remained in frontline service with some air forces into the early 1980s, testament to the soundness of the basic design. More than 15,000 Mustangs were produced during and immediately after the war, making it one of the most numerous American fighters of the era. Today, over 100 P-51s remain airworthy, maintained by collectors and museums worldwide. The sight of a Mustang in flight, often still wearing the distinctive markings of wartime units, serves as a reminder of the aircraft's role in establishing Allied air supremacy over Europe. The broader historical significance of the P-51 and its paper drop tanks extends beyond their tactical and operational impact. They represent a case study in industrial warfare and the importance of production capacity in modern conflict. World War II was decided not primarily on the battlefield, but in factories. The side that could produce more weapons, more ammunition, more aircraft, more vehicles, and more supplies faster than they were consumed in combat held a decisive advantage. The United States achieved industrial mobilization on a scale unprecedented in history. Peak wartime production in 1943 to 1944 saw American factories producing aircraft at rates exceeding 50,000 per year, ships at rates of multiple vessels per day, and ammunition in quantities measured in billions of rounds. This industrial output supported not only American forces, but also supplied substantial quantities of equipment to Britain, the Soviet Union, and other Allied nations through Lend-Lease. Germany, despite possessing significant industrial capacity and technical expertise, could not match Allied production. The reasons were multiple: smaller industrial base, strategic bombing of production facilities, loss of access to raw materials as territory was lost, diversion of resources to competing priorities, and inefficiencies in organization and planning. But perhaps most fundamentally, Germany was fighting a coalition whose combined industrial capacity was several times larger than its own. The addition of American industrial might to the Allied cause in 1942 to 1943 made Axis defeat inevitable once that industrial capacity reached full mobilization. The paper drop tanks falling across Germany in 1944 to 1945 symbolized this industrial reality in a form so simple and so stark that its message could not be misunderstood. The examination of captured American equipment by German technical intelligence services had been systematic and professional throughout the war. Facilities like Rechlin maintained detailed records of performance testing, material analysis, and technical assessments. These documents, many of which survived the war in various archives, provide valuable historical insight into how each side viewed the other's capabilities. German assessments of American equipment were generally accurate in technical terms. They correctly identified strengths and weaknesses of American aircraft, vehicles, and weapons. Where German analysis failed was not in understanding individual items, but in comprehending the scale of American production and the implications of that scale for the war's outcome. A single P-51 Mustang was a very good fighter aircraft. 10,000 P-51 Mustangs represented air superiority that no tactical skill or technical innovation could overcome. The story of German engineers examining paper drop tanks at Rechlin in March 1944 is ultimately a story about the nature of industrial warfare. It demonstrates that in conflicts between industrialized nations, production capacity becomes as important as battlefield prowess. The side that can build more, faster and more efficiently holds advantages that tactical and operational excellence cannot fully compensate for. This lesson, learned at great cost by Germany and Japan in World War II, influenced military planning throughout the Cold War and continues to inform strategic thinking today. The ability to sustain production of advanced weapons systems, to maintain supply chains under stress, to train personnel faster than they are lost in combat, and to outproduce an opponent over extended periods remains as critical now as it was in 1944. The March 1944 missions to Berlin, the first to be escorted all the way by single-engine fighters, marked a decisive turning point in the air war over Europe. From that point forward, no target in Germany was beyond the reach of American bombers with fighter escort. The systematic bombing campaign could proceed with losses that, while still significant, were sustainable. German war production came under increasing pressure. Synthetic fuel plants, ball-bearing factories, aircraft production facilities, and transportation networks all became targets that could be attacked repeatedly with fighter escort throughout the mission. The cumulative effect of this campaign, combined with Soviet advances from the east and Allied advances from the west and south, brought about Germany's defeat 14 months after the first P-51s reached Berlin. The paper drop tanks served throughout this final period of the war. Production continued through 1945, with thousands manufactured each month. The tanks were used not only by P-51 Mustangs, but also by P-47 Thunderbolts and P-38 Lightnings, extending the range of all American fighter types. British fighters also used paper tanks extensively. The Royal Air Force's Mustang squadrons employed them for long-range missions over occupied Europe and Germany. The efficiency of paper tank production freed aluminum and steel for other uses, while providing the range extension necessary for strategic operations. This optimization of resources, matching production methods to requirements and prioritizing efficiency over tradition, exemplified the industrial approach that characterized Allied operations throughout the war. Today, historians studying the air war over Europe recognize multiple factors that contributed to Allied victory: numerical superiority in aircraft and pilots, technological advantages in areas like radar and communications, strategic bombing of German industry and infrastructure, and the cumulative effect of sustained combat operations that depleted German resources faster than they could be replaced. The P-51 Mustang and its paper drop tanks were important elements in this multifaceted campaign, but not the sole decisive factor. The air war was won through the combined efforts of multiple fighter types, bomber forces, industrial production, pilot training, intelligence gathering, tactical innovation, and sustained commitment of resources. The paper drop tank represents one component of this larger effort, notable because it so clearly symbolizes the industrial advantages that underlay Allied success. The technical files maintained at Rechlin documented American capabilities with professional precision. German engineers recorded specifications, performance data, construction methods, and production estimates with the thoroughness characteristic of German technical work. These records, preserved in various archives including the Bundesarchiv, provide historians with detailed contemporary assessments of Allied equipment as seen through German eyes. Reading these documents today, with the benefit of historical hindsight and access to American records, reveals that German technical analysis was largely accurate. They correctly understood American capabilities. What they could not change was the strategic reality those capabilities represented. Understanding that an enemy possesses overwhelming advantages does not provide the means to counter those advantages when they are rooted in fundamental disparities of industrial capacity.